Okay, in this video, we'll be doing 1.4 question number 1 only. Okay, so and this is not just question number 1, this is a combination of question number 1 and question number 2, because in question number 1 they're asking us if it is terminating or non-terminating. Terminating means which has an ending, and non-terminating means which does not have an ending. For example, if I divide 7 by 5, okay, if I divide 7 by 5, 5 ones are 5, 2 in hand, we put a point, bring down a 0, 5 fours are 20, and done, kotom. This is terminating because it terminates. But if I divide 7 by 3, we do 3 to the 6, 1 in hand, put a point, 0, 2 to the 9, 1 in hand, 0, 2 to the 9, 1 in hand, and go on, and this will also go on and on. So that is a non-terminating. So they're asking us if this is terminating or not, or if this is not non-terminating or terminating. That's question number 1. Okay, excuse me. That's question number 1. If they're just asking us terminating or non-terminating, we just have to say yes, it is non-terminating, or no, it is not. Yes, it is terminating, or no, it is not terminating, or it is non-terminating. Okay, but in question number 2 they're asking us to find the decimal expansion of those in question 1 which are terminating. So terminate, they're asking us to divide it and see the result, or show the result after division. That's what question number 2 is saying. So question number 1 is basically just asking us if it's terminating or non-terminating. Question number 2, they're saying forget about the non-terminating. If it is terminating, then divide and see where it will terminate. That's what they say. Okay, so we'll do a combination of both. So we'll just see if it's terminating or not, and then if it's non-terminating, we'll just leave it and go. But if it's terminating, then we will divide the whole thing and see what the result is. Okay. So you can literally manually divide 3125 by 13. Put a point, 0, 0, 0, and then 312 timetable choice. But that is a very long and hectic process, so I'm going to show you a shortcut. So shortcut is you're going to take the denominator, only the denominator. Okay, the numerator doesn't matter. You're going to take the denominator and do prime factorization. So 5 6 2 5 5 1 2 5 5 2 5 5 5. After prime factorizing, you're going to write according to the power notation of the numbers. Okay, so 5 1 2 3 4 5. So there's 5 5s, so 5 to the power 5. Now very, very, very important thing, if in the numerator we don't care, let's say this is x. If in the denominator the form is 2 to the power m being any number, so 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 10, 20, doesn't matter. Okay, if it's like this, or okay, if it is like this where n can be any number, okay, or if it is together also, then only in these 3 conditions the numbers are then and only then. Let me just emphasize that the number is terminating. Okay, which means it has to be this alone, or they can be together. Otherwise, other than that, any other is non-terminating. So instead of 2 and 5, if suppose there's a number, let's say 7, if there's 2 to the power 7, it's going to be terminating. If it's 7 by 5 to the power 9, that's also going to be terminating. If it's 7 by 5 to the power 3 to the power 5, that is also going to be terminating. But as soon as you introduce something which is not 2 or 5, even if it's just a single one, it's going to be non-terminating. You introduce something like 7 or anything, let's say 5, no, not 5, 11 here, non-terminating. Got it? Big juto ikunai. What you're introducing should also be a prime number, obviously, because you have to prime factorize first. That's why we're prime factorizing first. So there cannot be into 4. You cannot say 5 to the power 4 into 4. Sorry, itu tu into 2 lah form di noy aku. Prime factorize screw lagi. You have to do it with prime number first. That way you get 2 square after prime factorizing. So it will terminate now though. Got it? So you have to prime factorize completely, and then after that other than 2 and 5, if there's any, it's going to be non-terminating. Okay, this is going to be very easy, so I'm going to do it real fast, and then I'm going to be skipping some questions. See, I'm doing Roman number 1, Roman number 3 I'll be doing, and then okay, Roman number 4 I'll do, and then 6 I'll do. After the rest, you're going to do it. Okay. So this is, yes, it is terminating. It will terminate. Okay, and in case you feel like you forget the formula or something, you can write since it is of the form 2m into 5n. You can write this also. Since no, not it, let's say since the denominator, okay, yes, it will terminate since the denominator is of the form 2m into 5 to the power n. Okay, so that you won't forget when you're doing it. So 5 class, it will terminate. So now the division part. So you can literally divide also, but I'll show you a shortcut method to divide these two. So our goal, okay, the main concept is to show that, is to make in every condition. Suppose I'll show you some conditions. And then okay, something like this. Okay, so I'm going to show you 4 conditions, like what you can do. Okay, so if it's only 5 something to the power something, 4 is, I'm just giving a random number, so you're going to multiply by the same power with 2. So in case it is 2, then you're going to multiply by the same power but with 5. Multiply and divide, I mean. And if they're together like this, you're going to look for higher power. So 5 load, not 2 load, 2 na. So 2 has a higher power, so 5, 2 to the power 5. So since 2 is the higher power, we're going to see how much is needed in 5 to reach this. So we know that when you multiply, it becomes x squared because the powers add up. So x squared into x cubed is x to the power 5, right? So it literally, this property literally works for numbers and alphabets, for anything, right? So if I say 5 squared, and if I multiply with 5 cubed, it should become 5 to the power 5 because the power should add up, right? So since 2 to the power 5 is the highest power, I'm going to multiply by 5 cubed by 5 cubed, so that it becomes 2 plus 3 is 5. So here also 2 is the higher power, so I'm going to multiply by 5 to the power 6 because 1 is already here. Okay, so this is what we'll be doing. I'll explain in a while why we're doing this. Okay, but then just for the timing, like this is the technique. Okay, so when we're doing this, I'll be explaining why we're doing this. So since 5 to the power 5 is there and there's no 2, so we added 2 to the power 5. Now the denominator, what will happen is the numerator, it'll be just like this. You get 2 to the power 5 is 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, so 32. But in the denominator, let me show you an example. If I write xy the whole square, you would write x square y square, right? The power is spread out. So I can go reverse, so xy the whole square. This is true for all, not only for variables, but also for numbers. So since the powers are same, now that we made the power same, we can write 5 into 2 to the power 5. 5. So now when you multiply 32 and 13, you'll get 3 to the 6, which is 9, and 3 2, which means 6 4, right? So by 5 to the 10 to the power 5. So whenever there's zeros on the denominator, all you have to do is, you don't even have to divide. All you have to do is count the number of zeros. So 10 to the power 5 literally means 5 zeros. 10 to the power 5 literally means 10 into 10 into 10, so 5 zeros. Okay, it'll have 5 zeros. So you can directly write from 5 zeros on the denominator means after the point there should be 5 numbers. So you're going to write 0 point, since there's 3 numbers, we need 2 more numbers. So 0 0 4 1 6. That way after the point there is 1 2 3 4 5 numbers. You can literally take out your calculator and try to divide 13 divided by 3125. You will get the same exact thing. So this is a shortcut to divide any terminating numbers, fractions, I guess. Okay, you can use this in not only this chapter but other chapters as well. So let's try with this. 4 5 5 5 9s are 5 1s are 7 1s are 7 3s are. So the here the denominator is 5 into 7 into 13. So it does not make, oh, before we do that, yeah, very important information again. See, I directly came here because I couldn't cut these two. I know that 13 in 13 table and 13 is a prime number, right? So at least try to cut it. If you cannot cut it, at least try to make the top part like, you know, prime number which hard with now, because if this is a prime number, okay, if this is prime number, then when you prime factorize, if you get 13 is one of the factors, you can cut the 13 13. Always remember that. So here also you can, in advance, if you can cut, but we cannot cut, so we'll just leave it as it is. So we're getting this. So in the denominator, it's not like I told you, we should have only 2, only 5, or 2 and 5 together, but this has 5 and 7 and all sorts of not, so no. Okay, it will terminate. It is non-terminating. So non-terminating. So number 4, let me do number 4. Number 4 we can cut. So 5 3s are 15, 5 3s are 15, 5 2s are 10, 0. So we're getting 3 by 2, 320. So 320, let's prime factorize. So 5 6 are 32. See, and when you're doing prime factorization method, you can use any prime number you want. Okay, it can be big, it can be small, doesn't matter. It's not like 2 rock rule like another. Yeah, you can do it by 5 also, you can do it by 7 also, you can do it by 11 also, but it has to be a prime number. Anyway, 5 6 are 30, 2 5 4 is 20. So if I do it by 2 2 3 2 2 16 2 8 2 4 2 2. So we are getting 3 by 1 2 3 4 5 6 2 to the power 6 into 5 to the power 1. So with what do you think we should multiply? We should multiply by 5 to the power 5, because 1 plus 5 is 6. So 5 to the power 5. Let's see what is 5 to the power 5. 5s are 25. 25 5s are 125. 125 5s are 625. 625 5s are 3125. Okay, so 3125 divided by 2 into 5 to the power 6, because this will become 6. This is 6 already, so we can take 6 common. This will become 10 to the power 6, which means after the point there should be 6 numbers. So 1 2 3 4 5 6. After the point there is 6 numbers. Since there's 4, I put 2 more zeros. Okay, anyway, number 5 also try it on your own. As for number 6, they've already done it half, like they've already done half of it for us, so you know, good for us, I guess. And this will be yes only, terminating. So if it's terminating, we'll have to divide. So let's see, equal to the power 3 into 5 to the power 2. What do we need? Or this one also we have to say yes, it is terminating. Excuse me. We need one more 5, so that it becomes 3 and 3. So 25 3s are 5 to 15, 5 1 3 to 5 to 10, 11. So that's 150. Yeah, I guess. So this will become 10 to the power 3. because 5 2s are 10 and then 3 common zone. I'm going a little fast. I hope you understand. You're understanding what I'm trying to say. And yes, for example, so you need fast calculations. So make sure you're catching up to what I'm showing you also in calculation fast forward try with position. Anyway, that's it, and here are the solutions of the questions that I missed. You can look if you did not get the answers correctly.